Hey guys, so here's the notes for 2.2. We're going to be talking about polynomial functions and evaluating them. So let's first talk about what is a polynomial function. It's basically we have y equals a times n to the x to the n, and plus a times n minus 1, and then x n minus 1, and then all the way to our constant, okay? So basically the idea here is that when we have our polynomial, 1, the a value cannot equal to 0, okay? Or our a sub n here. So basically the leading coefficient, and we'll talk about what that means, cannot be 0. 2, exponents need to be whole numbers. Okay. And then 3, coefficients are real numbers. So these are the 3 criteria that we need to make sure be satisfied in order to know if a function is a polynomial function. Okay? So our leading coefficient can't equal to 0. Exponents are whole numbers. So that means basically 1 and up. So 1, 2, 3, 4, 5, 6, 7, 8, etc. And then all the coefficients, remember those are numbers in front of our variables, are all real numbers, meaning we just can't have anything with I. Now let's talk about standard form. This is terms that are written in descending order. Of exponents from left to right. So that just means we start from the largest exponent and then we decrease from there. So if we have x to the 4th, then we go to x to the 4th, x to the 3rd, x to the 2nd, x, and then our constant. Okay? Okay, the leading coefficient. Basically, that is going to be the value or number on the first term. So basically, we call this a sub n, which we kind of saw up there in our polynomial. Okay. Okay, the constant term. So remember constant term, that is basically the term without a variable. And if we are writing a standard form, that should be the last term you see in standard form. So that might be something else we're going to put that. So last term when written in standard form. And then the last thing is our degree. So what is degree? That is basically going to be the largest or highest exponent. Okay. So when we are writing in standard form, that's going to be basically what's going to happen. It's going to be our largest or highest exponent there. Okay. Okay, so now let's talk about all the different types of polynomial functions. Okay, we have it when degree is 0. That is when we have the constant. So this could be when we have, for example, f of x equals negative 14. Very good. Okay, let's talk about when we have a linear. Okay, this is when we have a degree of 1. So this is what you guys have learned a lot. So something, or an example would be like 5x minus 7. Okay. Now, you'll see below in your notes all the different graphs. So constant, remember when we have degree of 0, that's a horizontal line. When we have a linear function, that means degree of 1, remember that's our diagonal. So either it will have a positive or negative slope. Okay. Then we have the quadratic. So that's what we just did in our last unit. So, of course, an example could be like 2x squared plus x minus 9. So remember, that makes a U shape when we have a degree of 2. That's our quadratic function. And of course, it either opens up or opens down. And it's what we call a parabola. So that's what the graph is. Okay, so those three should be very familiar. We've talked about them before. The next ones you might have heard of, but they're not something that we have talked so much in this semester so far. Next one is a cubic. What this is our degree is going to be 3. So an example of this could be x cubed minus x squared plus 3x. Now let's look at what could a cubic look like. So the graph of the cubic, okay, will kind of have like these 2 bumps, right? So we'll go from up, down, up. Or another way is if we reverse this, this could also look like a cubic. So that might be something else you might see, okay? Okay, now we have a quartic. So quartic is when we have a degree of 4. So we have x to the 4th plus 2x minus 1. Now notice when I did all these examples, I wrote them all in standard form. That means I went from the largest degree, okay, our largest exponent, which is our degree, and then I descended, meaning I went smaller in those exponents. Now what can a quartic look like? Usually it's going to look like a W, okay? So if we have the normic quartic or degree of 4, it'll look like a W, or if it's going upside down, it could look like an M, okay? Now the last one we have here is called a quintic. That is a degree of 5. So of course an example of this could be like x to the 5th plus 3, okay? So you just have that degree of 5 there. Now this is where it's going to have all these little different maximum and minimums, which we will be talking about more later on in this section, okay? But just know this is kind of what it looks like. We have where one arrow is facing down while the other one is facing up, just like we can see with like degree 1 and degree 3, where we have one arrow that's facing down, one arrow is facing up, okay? Okay, so make sure you watch the next video. That's where we're going to be talking about deciding if a function is a polynomial function.